Hi, this is Tom, and this is the second video of Lesson 18. And what I want to do now is let's also calculate the variance and standard deviation for set 2. So I should have ended with this variance, really that was for set 1, so I should have included the little 1 subscript on it. So that's how we should have written our first data set. Now, before we go on, I want to write this out a little bit more formally this time. In general, we write that the variance is equal to, we use this capital sigma, not the lowercase. So notice that I just wrote a capital sigma, whereas the symbol for variance and standard deviation is the lowercase symbol. So I say the sum, I go take the data minus its mean, we square it, and we divide by the number of data. And that's what we're going to use for our standard deviation, or for our variance at this point. And then if we wanted to find the standard deviation, we would just take the square root of whatever we found above. And that would give us our final answer. So let's try this. If you recall, let me bring up here is set 2. So I'm going to just copy it so we have it for easy visual reference. And let's bring it down here. And we're going to use our formula this time to calculate the variance. Okay. So here we go. So I'm going to write this out. Notice that we already know that the mean for data set 2 was 8. So if I wrote this out using the formula, I could write the variance this way. So I write sigma squared equals, so I write the data, well the first one is 3 minus the mean, that's 8. And then we square it, plus. We take our next data, that's the 5, we subtract 8, we square it, and then we add the next one. That's going to be a 7 minus an 8 squared, plus, then we have 9 minus 8 squared, plus 11 minus 8 squared, plus our last data value, 13 minus 8 squared. Take those and we divide them by the number of data, which is 6. And so let's see what we get here. So 3 minus 8 is negative 5. But if we square it, we get 25. Plus 5 minus 8 is negative 3, but we square it to get 9. Plus 7 minus 8 is negative 1, but we square it to get 1. Plus 9 minus 8 is 1, we square it, we get 1. Plus 11 minus 8 is 3, squared is 9. Plus 13 minus 8, that's 5, and we'll square it for 25. Put a line under all of that. We'll divide it by 6. And notice this one that I have, let's see, if I have 25, I'll use my highlighter here, I have 25 plus 9 plus 1. Well, 9 plus 1 is 10. 10 plus 25 is 35. And then look, I have the exact same numbers there, so it looks like I have a total then. I have a total of 70. I divide it by 6. So let's see, 70 divided by 6. Oh, you know what? We can reduce that a little bit. That's the same as 35 over 3. Now, the easiest thing and the wisest thing is if you don't need to, then leave the variance in the fraction. And when we find our standard deviation, we'll take it from the fraction and not an approximated decimal. And we'll get a better result that way. So you take the square root of 35 thirds. Let's go to Good Grapher and see what we get. So I take the square root of 35 divided by 3. That's going to be 3.4. So I get 3.4. 3.4. Now, what does that mean? Well, let's go back to where we began at the very beginning. So I'm going to return to the top, and I'm going to just, you know what, we can work right here. Actually, I'm going to bring this down because I think it'll be easier to compare this way. So what have we found? Here's what we found. Our second data set has a standard deviation of 3.4. Our first data set had a standard deviation right there, you can see that, of 1.3. And what it tells us is what we have actually observed. Oh, I lost a dot there. That it should have a dot. Notice this. The 1.3 is a smaller number. And notice that there's less distances between the data. So a smaller number indicates that the data is closer together. If we look at set 2, notice how far everything is apart. And it just keeps getting further and further and further away. Because we have such large distances here, then we have a larger standard deviation. So if someone was to just say, well, I have two data sets and they have the same mean, well, at that point, all you could know is that the mean is 8. However, if they changed that information and said, well, I also have standard deviations, then you know quite a bit about the data. So that's why we measure the visual spread using variance and standard deviation. Thanks for watching.